So today we're going to be looking at this problem right here, 3x to the negative second y divided by 2x to the negative 6y cubed. All of that is being raised to the negative second power. Because we have a negative exponent here, we are first able to use the negative exponent property, which says whenever I have a power to a negative or a base with a negative exponent, I can reciprocate or I can flip it. So rather than writing it as a to the negative n over 1, I can write it as 1 over a to the positive n. Notice that when we reciprocate, the exponent becomes positive. So you'll notice here in this problem, I reciprocated the denominator and the numerator. I flipped them around and made it 2x to the negative 6y cubed over 3x to the negative second y, now being raised to the positive 2. So all I did was I flipped it and made the exponent positive. Notice that none of the exponents in the base here changed. X to the negative 2 is still x to the negative 2 down here. Moving on to the next step, now we're going to simplify this exponent. So we're going to take each of these factors, so 2 times x to the negative 6 times y cubed. So this is a product here. And the product to a power property states if I have two factors, a times b to the n power, that's the same as a to the n times b to the n. So here I take 2 squared, which you'll see here, x to the negative 6 squared. Now to simplify this, we need the power to a power property, which says when I take a power, such as a to the m, to another power, we get a to the m times n. So we're multiplying our exponent. So here, it's x to the negative 12 because negative 6 times 2 is negative 12. Lastly, we have y cubed squared, so that's going to be y to the 6th. We're going to do the same thing to our product in the denominator. So 3 squared, x to the negative 2 squared is x to the negative 4, y squared. Now we're going to have to simplify these exponents here, x to the negative 12 divided by x to the negative 4. Our simplified answer can only have one exponent with the base of x, so we have to simplify this first. So x to the negative 12 divided by x to the negative 4. Well, when we divide exponents with the same base, we get the same base out, but we subtract their power. So here we're going to do negative 12 minus negative 4, which if we do keep, change, is negative 12 plus positive 4, which is negative 8. Notice the base remained the same, x, still x to the negative 8. We do the same thing here, y to the 6th divided by y squared. 6 minus 2 is 4, y to the 4th. Both of those quotients we write as part of the numerator. Okay, we will have to go back and simplify x to the negative 8, but at first we're going to write our quotients in the numerator. You can also see here I did 2 squared, which is 4, and 3 squared, which is 9, so we can simplify those at any point in time. Okay, this is not simplified completely still because we have a negative 8 exponent. Okay, we never have negatives if it's simplified completely. So our last step here is to, again, apply the negative exponent property a second time here and take a to the negative n and reciprocate, make it 1 over a to the n. So here we take x to the negative 8 and move that to the denominator, becomes x to the positive 8. If you notice 4, y to the 4th, and 9 do not change here. They do not have negative exponents, so 4 and y to the 4th remain in our numerator. 9 and x to the 8th remain are going to be in our denominator. This is simplified completely because we have no negative or 0 exponents. We only have one exponent with the base of y, one exponent with the base of x, and the fraction 4/9 cannot be simplified. So this right here is our final solution.